This is my report for Physics Lab 1. So as an introduction, the goals were to evaluate the effects of charging pieces of tape, and to do this we were determining the charge of tape using an object of known charge, which we used a pen for this case, as well as determine the amount of charge on the piece of tape. We used tape, pen, ruler, and two thick books to hold the tape up, you'll see later. And then we found that the charge tape is positive, which ended up being 2.06 times 10 to the negative 8th coulombs, and the electrons lost total were 1.28 times 10 to the 11th atoms, or electrons. And then the key physics behind this is Newton's second law, which we saw a lot in Physics 1. And the key thing here is when there's no change in velocity, there's no change in momentum. So this means the net force is 0, and when there's two forces, they're equal and opposite when net force is 0. And then also Coulomb's law, this is new, where you can see it to the right here. K is the Coulomb's constant, and it's assumed to be 9 times 10 to the 9th here. And then Q is the charge of the objects. R is the unit vector that points from the object creating the field to the object we're observing. In this case, the source is tape 1 and the system is tape 2. We'll see. So for the experiment, the initial conditions are two charged pieces of tape placed at distance x, which is much greater than r, where r is the minimum distance for the two tapes to interact. So at x, they're not interacting, that we can see. And also, before the experiment, there were two pieces of tape that were 22 centimeters long that I charged, causing the electrons to migrate. And then tape 1 was brought near my hand and a pen to determine the charge sign. Tape 2 was tape B in this picture, and tape A was tape 1. And I did this experiment to see where they interacted. And I found that the charged tape was attracted to the pen, which is known to be negatively charged when rubbed in your hair. So the tape was also attracted to my hand and repelled by the other piece of charged tape. So this means that because it was attracted to the negative pin, the tape has to be positive. This also means that it was attracted to my hand because it was charged, and it polarized the skin of my hand, drawing the electrons near it, leading to attraction. And it also means both tapes had the same charge, which is why they repelled. And the results, you can see my work on the right here, working through starting with the measurements and then working through the force of gravity, which I found to be 0.0031 newtons, which is equal to the electric force because of Newton's second law. And the amount of charge was found to be 2.06 times 10 to the negative 8th coulombs, and the number of electrons lost, you can see here, 1.28 times 10 to the 11th electrons. This is found by dividing the charge of the tape by the charge of one electron. And then the ratio of deficient electrons to total atoms, 3.06 times 10 to the negative 7th, which means there's that amount of deficient electrons for every atom on the piece of tape. Oh, and the amount of atoms on the tape is found using the area in the area of an atom. So the errors and assumptions, or the sources of error for this experiment, are I assumed the tape to act as a point charge, but it's actually not a point charge. So this could lead to some degree of error. Also could have unequal charges between tapes, error in measure distance where tapes first interact, or handling could modify the charged tapes, such as if I touched the middle by accident. And then furthermore, what if the tape was repelled by the pen rather than attracted to it? This would indicate that the tape was negatively charged, and the tape would still repel itself from other charged tape and be attractive to the hand, however. So the results would be the same, except I would think the sign was the opposite. And why does this matter? Well, it matters that we make sure the tapes are properly charged, because one charged and one neutral tape would result in attraction because the charged tape would polarize the neutral strip, and this would have incorrect results, obviously. And this could happen through improper handling, such as touching the middle, like I said before, or charging the tape incorrectly.